Okay, to learn how to integrate the linear, to find the solution for a linear type differential equation, we have to know what is the integrating factor. So you know what is a factor. Let's say I have 2x squared plus 6x, then the factor is 2x and then x plus 3. Am I right? Because 2x, we can have all with the term 2x here. Every term has the common one, 2x. That's why you can take out. That's why it is called a factor. Okay, so now we come back to our problem. Let's say I have this. This is y e power, let's say x squared. So when you differentiate this is just like a house. Okay, this house with two persons staying here, and then they are going to take turn to use the toilet. So you have ex squared, then y will use the toilet. Inside the toilet we have d dx, that is the toilet bowl, and then y will sit on the toilet bowl plus, and then the y will wait outside now, and then ex squared will use the toilet. So we differentiate this one is 2x, isn't it? Or actually this result we can write it like this: ex squared dy dx plus 2x ex squared y, this is the same as d over dx y ex squared. That means just now I said two persons use the toilet, that's why the toilet being used twice. So here the toilet being used twice, that means there are two persons in the toilet who are in the house. Who are in the house? There are two persons in the house. Who are they? One is y, one is ex squared. Correct or not? Yes or no? Okay, now we look at another one. Let's say I give you d over dx, and then this is y e sine x. Okay, we differentiate this one. Okay, again two persons in one house with only one toilet. So that means e sine x, wait outside, that let y use the toilet first. Whoever use the toilet first also same. Okay, then plus. Okay, now y will wait outside, and then e sine x will go into the toilet. So differentiate, you get cos x. Okay, so therefore we can also write like this: e sine x dy dx plus cos x e sine x y. This is the same as d dx and then y e sine x. So you see these two, for these two. So this one you see all common term, ex squared, ex squared, ex squared, all with ex squared, ex squared. So this ex squared is called the integrating factor. This is called a factor because every term has ex squared. Here you see every term they have e sine x. So this is called the integrating factor. Okay, this, or we call it IF, integrating factor. Okay, so all the terms they have the same, the common one. And then again, just a reminder, of course you cannot say this one equal to this. Okay, you cannot say this one equal to this, cannot, because this one you see we have two terms, isn't it? Just like I said, two persons, they are going to use the toilet. So how can here only y use the toilet? How about ex squared? So it cannot. That's why two persons, the toilet must be used twice, two times. Okay, so one time for y to use, the other time for ex squared to use. Same like here. This is called the integrating factor, and then you cannot say this one equal to this, or this one equal to this, without like this. You cannot say this one equal to this, or this one equal to this, because this house got two persons staying. So they stay in this house, so they must have, the toilet must be used twice. So y go to the toilet, e sine x go to the toilet. Okay, so like this. So this is the integrating factor. Okay, and then next you just see how to get the integrating factor. You see like here, in this case, the integrating factor, actually the integrating factor also usually is exponential, is an exponential function. Then how to get this ex square? Actually, this ex square and this 2x, they are related. Because that means you just integrate, you integrate this, then you will get the x square, isn't it? You integrate this, then you get this. The same thing here. Here, how do you get? You see, the integrating factor is this. What is the relation between these two? You integrate this. Exponential, that means you want to find the integrating factor, you just take this e and then you integrate this. That is the integrating factor. So when you integrate, you have e sine x. Is it? That is the integrating factor. Okay, so take for example, I give you this one. Let's say I give you this one. dy dx plus, okay, let's say this is 3x y, okay, equal to something, let's say x. Okay, so this is a linear type. Okay, I want to get the integrating factor. How do you get the integrating factor? Okay, let's look at here. The integrating factor is always e, exponential. So the integrating factor is an exponential, and then you integrate this. Integrate the 3x. So that is the integrating factor. So the integrating factor will be e 3x squared over 2. Because you integrate x, it will be x squared over 2. So the integrating factor is e 3x squared over 2, e 3x squared over 2, e 3x squared over 2. That is the integrating factor. So after we have the integrating factor, then you see, okay, you don't look at this side yet, you just look at the left hand side. Okay, so you see the differentiation twice. That means you involve two persons. Here the y use a toilet, here the y wait outside, and then this one use a toilet. That means this one actually, don't look at this side, look at this. That means this is actually differentiate. That means this house stay with two persons. Who are the two persons? The two persons are, one is y. Okay, this one is y in the toilet, y. And then the other person is the one who are waiting outside. Okay, so this become like this. So that means we can simplify like this. The two terms we can simplify into one. That is what we are going to do for linear case. Okay, take for example, I give you another example. Let's say I have this. Okay, let's say this dy dx. Okay, and then let's say this is minus 1 upon x y. Okay, here can be anything. Let's say here is x cubed. Okay, you see this is linear type. Let's say I already expressed in linear type. This is linear type. Okay, so the next one is I have to find the integrating factor. So the integrating factor is always an exponential function. It's always exponential, no other thing else. And then we have to integrate this. We integrate negative 1 over x dx. We integrate. Okay, it's negative x. So when we integrate the integrating factor, we have e negative ln x, isn't it? E negative ln x, correct? And then when I integrate e negative ln x, that means my integrating factor will be e, okay, simplify the exponential function, I have 1 over x. Then the integrating factor is 1 over x, isn't it? So if the integrating factor is 1 over x, what does it mean by factor? That means every term must have. So come back to this. That means everybody must have this. dy dx minus, okay, this is 1 over x, 1 over x, the integrating factor. And then this is x cubed 1 over x. So this will be the integrating factor. So this will be the integrating factor. Everybody must have. That's why we call it a factor. Therefore, with the integrating factor, of course, we can simplify first. We can simplify. Okay, you get this. This is x squared. So after that, you see this one. Don't look at it. This one is okay. This one no problem. We just look at this side. You see this one, the toilet being used twice. Then that means this house. This is a house here. This house staying with 2 persons stay inside. Who are staying? One is y. The other one is 1 over x. That's why 1 over x is waiting outside, y is inside. Okay, so this is the one. That means we can simplify this, or we can shorten this to become like this. This is what we are going to do when we do the linear type. Okay, so let's say I give you another one. Okay, let's say I have this 2x, okay, dy dx, okay, plus y equals to x squared e, let's say 2x. Now this one, okay. So what we are going to do now, okay, I change this one to, let's say, x squared. Make it a bit more difficult. Okay, so what I do, I have to change this one into linear type first. Okay, dy dx, this is y. I say already, for linear type, this one must be always 1. So how to make it 1? I just change it like this. Then divide x squared e 2x divided by 2x squared. Is it? So I just divide like this. Okay, now this is already linear type. And then for linear type, now I have, don't look at this side. Now we look at this side. We are going to find the integrating factor. We can find the integrating factor. So the integrating factor will be, is an exponential function, and then you integrate this. Half, take out 1 over x squared dx. So this one will be the same as e half, and then integrate this x negative 2. What shall we get? So the integrating factor will be e half, then this is x negative 1 over negative 1, is it? Correct? So we get e negative 1 over 2x. Correct? Okay? So now we come back to our linear type. This is dy dx. Okay, this is 1 over 2x squared. This is y. And then here we have this one cancel. We have e 2x over 2. So what we do now, we multiply with the integrating factor. Everybody, all we multiply. So e negative 1 over 2x, e negative 1 over 2x, e negative 1 over 2x. So integrating factor. So now you don't look at this side, okay? Don't look at this side. We look at this side first. Now I'm teaching you this side. How to simplify this. So you just put like this, d dx, okay. Here, that means we have the toilet being used by 2 persons. That's why being used twice. That means there are 2 persons staying inside this house, and then one of them is y. There you see y sit on the toilet, on the toilet bowl. So y, and then e negative 1 over 2x. And then this one will be, you have half. Some half, then e, this one minus this, then 3 over 2. And like this. So this is a 1. Okay? So that is how we change. So the most important thing is, why you want to find the integrating factor, so that with the integrating factor, we can shorten it, or we can do it like this. So we can combine these two to become 1. then it will be easier. Just like here just now. Why you need the integrating factor? You need the integrating factor so that you see with the integrating factor, now you know this house got two person. One is Y, the other one is this. Okay, so all the same. So next one I will show you how to solve the linear differential equation. Okay, and then you remember this. Why you need? Okay, I told you already why you need the integrating factor, so that from here we know, okay, the two person is Y and the integrating factor. Okay, and then same thing here. Why you need the integrating factor? That means this house got two person. One is Y, the other one is the integrating factor. Okay, so we are going to do how to solve the linear differential equation by means of integrating factor in the next video. Okay.